research methodologist. You are in for a treat this week. Today, I am giving you one of my favorite lectures. I don't even know why it's one of my favorite lectures. I think I like it because, number one, it's super concrete. It's really easy to understand. Actually, it's so easy, it's almost fun, at least for me. Um, it is also very, very helpful when you start thinking about your variables and thinking about your paper. This, believe it or not, is sort of laying the background to make statistics super easy for you. At least that's my goal. So, welcome to Lecture 7, Operational Definitions and Measurement Basics. So, here's what we'll be covering today. Operational definitions, which you already know what they are. I'm just going to reinforce them. We're going to talk a little bit about, again, more about hypotheses and how to set them up. Then we're going to talk about measurement and finally define 4 different scales of measurement. So 4 things today. Lace up your boots and let's go. The first thing we're going to talk about is operational definitions. And I just told you that you know what these are, even though you don't know that you know what these are. In order to go over them, I'm going to review what we talked about last lecture. I'm going to review the definition of a formal hypothesis, or plural hypotheses. A formal hypothesis is a specific statement about the expected relationship between 2 variables. It's a prediction, an educated guess. If A, then B. The variables must be operationally defined, explicitly and implicitly. Let me give you an example. Let's say that if my dog sees a cat, he will bark. Okay? I've got 2 variables, seeing a cat and barking. And I am predicting a relationship between them, at least in the little mind of my dog. If my dog sees a cat, then he will bark. That's a hypothesis. It's a specific statement about the expected relationship between the 2 variables, cat and barking. It's an educated guess. It's a prediction. And I can tell you it's pretty true because I know my dog pretty well. If my dog sees a cat, then he will bark. Now here comes the kind of tricky part. Remember that science is empirical. It must be something that we can all see with our 5 senses, that we can all agree is actually there in the real world. So therefore, the variables must be operationally defined. So in this particular case, I'm defining a cat as a 4-legged small animal. Might have some pictures so we all know what a cat is. We all know what a cat is. That's defined well. And then I'm defining barking as a loud noise coming out of my dog's mouth that sounds like ruff, ruff. Okay? Those are operationally defined. And actually, I think cat and bark are well enough words that we know what they are. So that's explicitly defined. We have defined our variables as cat and barking. Okay? We know what those are. Everybody knows what those are. But what would happen if we said, if someone is Asian, then they are smart? Okay, some of you guys might be like, yeah, completely, I know, right? And some of you guys might be, what? So let's say that's our hypothesis. I'm just being silly here. If someone is Asian, then they are smart. Okay, now we have to study that. We have to measure it. How do you measure Asian? I mean, let's see, they could be Japanese, Chinese. Could they be Hapa? Could they be Filipino or Filipinos Asians? But they're Catholic. Many are. I don't know. Stereotyping here completely. But we have to define Asian a little more clearly. And I would say You can define it however you want. You can say 100% either Chinese or Japanese or Filipino, or you can say 75%. It doesn't really matter. You just have to define it. That's operationally defining. Then the second half of that hypothesis would be SMART. Define SMART. And we've run into this problem before. Are they good at math tests at school? Are they good at reading tests? Are they good at playing video games? That's one type of intelligence. So in order for my hypothesis to really mean anything in the study, I have to state what I mean by my variables. I have to state what I mean by Asian, and I have to state what I mean by SMART. And that's an operational definition. I have to state what I need so clearly that anybody reading that article would know what I mean. So it's not enough in today's day and age to say Asian. There's so many different, the world has gotten so small that we know there's a lot of varieties of Asian, just like there's a lot of varieties of white people. So I have to be very specific about how I define Asian and how I define intelligence. So if I am, now they have to be defined specifically, but they can be stated two different ways in a paper that you will, any of the papers that you'll read for your project or any other scientific literature. I'm going to make you define them explicitly in your papers. So for example, if your overall question is that Asians are smart, or your overall hypothesis is that Asians are smart, you would say, if someone is Asian, then they were smart. And then after that, you would say Asian is defined as 75% of the Asian races as defined by the US Census. And smart is defined as getting good grades in school and at UH Manoa. So those are explicitly defined. They can come in the middle of your hypothesis, but that leads to a very, very long sentence, or they can be the sentence right after your hypothesis. That's explicit. Right with your hypothesis, you're telling the reader exactly what you mean by your variables. Now, sometimes in articles you read, the researchers aren't as clear. They are trying to save space with their articles, and they also are relying on the fact that anybody reading a scientific article has got to have at least some knowledge of how these articles are set up. So their variables are defined implicitly. So for example, they might end their introduction section with a hypothesis that would say, if someone is Asian, then they are smart. They wouldn't follow that with an explicit definition, but if you turn to the method statement, the method section would have a section called measures and would spell out exactly what they meant by that definition. Or let's say, for example, males aged 18 to 21 will have higher self-esteem than females aged 18 to 21. In most cases, we don't really need to define male or female, but self-esteem we would want to define. So if we saw that statement in a research article, if we wanted to know how they defined self-esteem, we would turn to the measure section and they would say self-esteem was measured by the Rosenberg Self-Esteem Scale, a test of self-esteem. And then we'd know what their operational definition is. So the point of this is that a hypothesis is a little bit more than a statement about the expected relationship between two variables. Each of the variables must be operationally defined, must be defined so specifically and so clearly that anybody could agree that that was the definition. So the technical term that you'll hear in research methods circles is that the variables are defined in the operation used to measure them. That's the variables are defined with the operation used to measure them. That is sort of ugly. What they basically mean is the variables are defined by a test or an observation or some other observation that's some other way of defining that's crystal clear, that's empirical. So again, an operational definition is a definition of a variable in terms of the operations used to measure it. It's got to be clear, crystal clear. It's got to be measurable. We have to be able to either ask someone about it or be able to directly measure it. And it must be directly observable. So, for example, let's say children that grew up in communities with adequate amounts of fluoride in the water will have fewer cavities than children who didn't. So let's say that's my hypothesis. I'm making a prediction that kids who grew up in places where they had fluoridated water in the wells would have better oral hygiene, would have fewer cavities than those who didn't. So I can measure those things. I could ask people where they grew up, and I'm sure somewhere there is a big book with all the communities in the United States, measurements of fluoride in the water. It's kind of a big deal. So that's measurable. And then I could also ask them how many cavities they had, or go get their dental records and see how many cavities they've had. Both of those things are clear, they're measurable, and they're directly observable. And by that, I don't mean that we see the fluoride in the water. I mean that some facet of that measurement is observable in the sense that anybody could look at the same information that we're looking up and agree on it. So that's an operational definition. A definition of a variable that is so specific, we know exactly what it is and how it's measured. Okay, I'm going to give you some examples. Let's say I want an operational definition of love. So, can you see love? Maybe say you can see it on somebody's face, but people wouldn't agree on that. Some people might think it's love. Some people might think it's indigestion. That's so funny. One thing you could do was observe behaviors. And a colleague of mine at UC Davis did exactly that. He was studying adult attachment, and he watched couples say goodbye to each other at the airport. And his graduate students had a clipboard, and they sat very slyly in the airport so nobody could see them. And they chose a couple to look at, and they began looking at the couple about 10 minutes before the one couple was going to the gate, and they counted how many times they touched, how many times they kissed, how long of a time they held hands. They had a whole list of checklist of behaviors. That was how they defined whether the couple was in love. Another thing, easy way, and I've mentioned this quite a few times, is a test. A test can be an operational definition of something. So here's an example of a love test. How good are you at loving others? Take our true love test and true love quiz and find out. Now, the point about operational definitions, they're great. They're really, really great because they're empirical, they fit the scientific method, we can measure them, we can agree on the results of the study. But the problem is that we might not be measuring what we think we're measuring. Just as kind of a silly example, let's say one of our definitions of an observation of love in a couple would be how close they are to each other, how often they touch. Well, they could be touching each other because they're cold, right? You don't not necessarily mean love. Or a quiz, I don't know about you, but I've taken some quizzes that do not accurately describe me at all. So just because a quiz says it's a love quiz, it is not necessarily measuring love. So operational definitions are great in that they can be measured, but they're not so great in the sense that they may not adequately represent the construct that we want them to represent. And that goes back to what we talked about, I believe it was the first day of class, when we talked about facts and inferences. The facts are what we see, either through the results of a test or by direct observation of someone. And the inference is what we think it means. And sometimes we're spot on, but sometimes we are not spot on our measurements. And Research Methods has a way to adjust for this, and I'm going to talk about this in the next lecture. Here's another operational definition. I found this on the web. It's an operational definition of homelessness. It was a part of a study where researchers were interested in where homeless kids went after they were in the hospital. When they were sick, did they have a safe place, a healthy place to go when they healed? And I was really shocked when I saw this because this study needed an operational definition of homelessness. But if you read these, you'll think about it. Homelessness includes camping with no permanent home to return to, doubling up temporarily with another family, having no permanent place to return to after hospitalization, living out of a car, or living in an emergency or transitional shelter. Now, that's a clear definition of homelessness. Very last one of our examples of operational definitions, it has to do when I worked in a retail store when I was in college, back in the Stone Age. And one of the things that they always made us do when we made our displays in the store on the mannequin, they always made us put lots of accessories on them. So we couldn't just put, a top and a shirt. A top and a shirt. Mannequins need pants. We couldn't just put a top and pants. We'd have to put a belt, a necklace, a purse. We'd have to totally dress those mannequins up because the company believed that if people saw accessorized mannequins, then they would buy more stuff. So that's a hypothesis. If people see more accessorized mannequins, then they will buy more stuff. But how do you operationalize buy more stuff? Well, the company did it several different ways, and we got our performance reviews had all these statistics on them. The first way that they defined it is in total sales for the day. Everything you sold for the day. Another way they defined it was the dollars per transaction. So they wanted you to have big sales. You would actually get in trouble if people would go to the register and only buy one thing. They wanted people to buy lots of things. They also wanted people to buy more than one accessories. They wanted people to buy accessories. So those were their examples, their operational definitions of buy more stuff. More than one item and lots of accessories with the items. So that's another example of an operational definition. So what would an operational definition with those variables look like? Consumers who see displays with accessorized outfits will spend more money than those who do not. So our variables are accessorized outfit and spend more money. And note that this is a prediction and these are operational definitions. Here's another example. Children who spend at least 5 hours a week with their grandparents will have higher scores on a self-esteem test than those who do not. Okay, so basically what we're saying that spending time with grandparents helps children have higher self-esteem. What are our variables there? Time with grandparents and self-esteem. Right, I know you were just shouting those out wherever you are. So notice that we've got our variables are operationally defined. time is not just any time, it's 5 hours a week. Self-esteem is not how much they puff their chest out and stand up straight. It scores on a self-esteem test. So we've got operational definitions and a prediction. So at this point, if we were in the wild or in the classroom, we might have a little discussion of what your hypothesis is. I think, just for fun, I'll put up a forum for this week so you guys can put up your hypotheses and get some feedback from me or the other people in the class on your variables and your operational definitions. So I'm going to take a little break right now, and I will see you again next time you open your computer and download a file.